Hello, welcome to this lesson of our study of differential equation. Okay, so in this lesson, we'll go through how to use some informations given, particularly some conditions given to solve for the particular solution of a differential equation when you have the general solution. Okay, so all that you've been doing from the introduction up to this point are the things you'll be doing when you are actually solving differential equation problems. Okay, so I want us to cover those parts. Then when we start solving differential equation problems, we just use those terms, or you just use those ideas straight away. Okay, so given that, this is the first question. Given that y equals c1 e to the negative x plus c2 e to the 3x is a general solution of the differential equation this. Okay, so you know that this equation given is a general solution to this differential equation. Determine a particular solution if y of 0 is this and y prime of 0 is this. So here, before we start solving this, or before we start determining a particular solution, let me first talk about what this information means. Once you have a differential equation subjected to these, normally what you get is you get the differential equation to be this. Okay, then you'll be asked to solve this given these conditions. Okay, and probably when you solve, you get the solution there. But I'm just going through with you how you use the conditions given to find your particular solution in case you get your general solution. Okay, so here you can see that there's a y of 0. So here x is 0 here. Okay, and here 2x is also the y prime of 0. So it means at the same point of x, so of these two conditions, this one and this one, we have x equals 0, and we are just evaluating y of 0 at y at s equals 0 and then y prime at s equals 0. So since we are starting from the same point of x, okay, for both conditions given, this one, the y of 0, this one, and then y prime of 0, you see the x is the same for both, then this set of condition is called initial conditions. Okay, so it is initial because the condition is given at the same point. So we assume that the initial point of x is 0. Okay, and then the problem we have here, this differential equation problem, is what we call initial value problem. So when you hear of initial value problem, it means there's a differential equation subjected to initial conditions. Okay, so let's quickly go through how you will use these conditions to find your particular solution. So given that y of x, or y, is equal to c1 e to the negative x plus c2 e to the 3x, okay, is our solution to the differential equation that was there. Okay, subjected to y of 0 equals 3 and then y prime of 0 equals 4. What you do here is very simple. This is your solution, so you find y of 0 from this solution. So it means that y of 0 from the solution given here is wherever you see x in that solution, you put 0 there. So c1 e to the negative into bracket 0 plus c2 e to the 3 into bracket 0. Okay, so here what this means is negative 1 times 0. Okay, and so negative 1 times 0 is still 0, so e to the 0 is 1. So I have c1 plus c2, because here too you get e to the 0, and that is also 1. Okay, now we said y of 0, this is y of 0 from the solution, but the condition is saying that y of 0 should be equal to 3 from this one. Okay, so this should be equal to 3. So you have the first equation to be c1 plus c2 equals 3, equation 1, like that. Very simple. Now the second condition, this one is saying that y prime of 0, so it means we need to find y prime from the question, or the general solution given. Okay, so y prime is simply equal to negative c1 e to the negative you know how to differentiate exponential functions. Okay, e to the negative x and plus 3c2 e to the 3x. Okay, now we are saying that y prime of 0 is equal to what? 4. So this, when I use this is my y prime. So y prime means that, or y prime of 0 means that wherever I see x, I put 0 there. So I have c1 e to the negative 1 into 0 plus 3c2 e to the 3 into 0. Okay, and what would this give me? Give me c1 it will give you another equation, C1, or there is a minus here, sorry, so there should be a minus in front of this. So we have minus C1 plus C3C2 should be equal to what? Y prime of 0 is 4 from this condition, so this whole thing should be equal to 4. So we have the second equation being that negative C1 plus 3C2 equals 4. This is my second equation, that's equation 2. So I have this to be my equation 2, negative C1 plus, and then this is our first equation, okay? So you solve this simultaneously. C1 plus C2 equals 3, equation 1. You have negative C1 plus 3C2, okay? C2 equals 4, equation 2. Sorry, let me clean this. 4. I have equation 2, right? So when I add these two equations, I'll have C1 minus C1. So I have C1 plus negative C1. That will give me 0. And I'll have C2 plus 3C2 in the I'm solving the left side. So I have 4C2 equals 3 plus 4, which is 7. So this implies that my C2 is equal to 7 over 4. And then from equation 1, C1 is equal to 3 minus C2. And when you put it here, we get 3 minus 7 over 4, which is equal to what? You do your calculation yourself and you have 5 over 4, okay? So my C1 is 5 over 4, C2 is 7 over 4. So this means that the particular solution y is equal to C1 e to the negative x, and C1 is just 5 over 4 e to the negative x plus C2, which is 7 over 4 e to the 3x. And in fact, this is equal to 1 over 4 into 5 e to the negative x plus 7 e to the 3x. There is a particular solution, okay, from an initial value problem, okay? So I hope you get this. So in solving differential equation, we'll get to a point where we'll get a general solution given, and we use the conditions to solve them. So I'm just going through with you how you do that. And the second question is find the particular solution to the differential equation. This is it, okay? With the general solution, this one, okay, y equals C1 sine 2x plus C2 cos 2x with these conditions, okay? Now these conditions are different because we don't have, look at here, we have y of pi on 8 is equal to 0 and y of pi on 6 is equal to 1. These values are different, okay? So since we are evaluating them at different points of x, we call this boundary conditions, okay? So we call this boundary conditions. These are boundary conditions, and then the differential equation that comes with that is boundary value problem. So we call it BVP. So when you see a BVP or when you hear of boundary value problem, what they mean is that the conditions given at different points of x. So you can get a condition like y of 0 equals, let's say, something, okay, and y prime of, let's say, 2. So since these conditions are not the same, or these values of x are not the same, you have a boundary value problem, okay? So in the boundary value problem, you can still get y prime of something, just that the points of x, or the point where we are evaluating our function, should be different, okay? So here let's rewrite the question. We said y is equal to c1 cos or sine. Is it sine or cos? Yes, sine. C1 sine 2x plus c2 cos 2x. Then the condition is y of pi on 8 is equal to 0, and then y of pi on 6 is equal to what, 1, right? Okay. Yes. So what happens here is that first of all you find y of pi on 8, okay, and this is equal to c1 sine of 2 times pi on 8. So wherever you see s, you put pi on 8 there, and 2 times pi on 8 will give me pi on 4, okay? Then plus c2 cos of pi on 4. And pi on 4, you can put your calculator in radians and evaluate this, or you can convert it to degree. Pi on 4 is the same as 45 degrees, okay? So sine of 45 degrees will give you root 2 on 2. So I have c1 root 2 over 2 plus C2. Cos of 45 is the same thing as root 2 on 2. And we are saying that y of pi on 8 should be equal to what? 0 from the condition. So this is equal to 0. So if I divide through by root 2 on 2, I mean every term root 2 over 2, this term root 2 over 2. Okay, you can see that this is the same as this, so this will cancel this will cancel the 0 divided by root 2 on 2 is still 0. So I wouldn't write that. I wouldn't write that. Okay, so I'll just write a simplified form of it. Now we have C1 plus C2 equals 0. Our first equation is this. Okay, so you can simply say that C1 is equal to minus C2 and put it there, or C2 equals minus C1, anyhow you want to, or you can say C2 is equal to minus C1, anyhow you want to put it. Okay, then you go to the next condition, we say that y of pi on 6 is equal to 1. Okay, but in this general solution, y of pi on 6 means that wherever I see x, I put pi on 6 there. When you put pi on 6 in this side, you get 2 times pi on 6, and that will give you what? Pi on 3. So you get C1 sine of pi on 3. Okay, so I have C1 sine of pi on 3 plus C2 cos of pi on 3. Okay, and when you evaluate this, what will you get? This will give you sine of pi on 3 means sine of 60 degrees, and that is root 3 over 2. Okay, sine 60 degrees is root 3. So I have C1 root 3 on 2, then plus C2 times half. Cos of 60 is half. And we are saying that this should be equal to 1. Okay, so I have C1 root 3 on 2 plus C2 over 2 is equal to 1. When I multiply through by 2, I have C1 root 3 plus C2 equals 2. And this is our second equation. Okay, so with the second equation, what you have to do is just C2 is equal to what? Okay, so we go back to our first equation. We are saying C2 is equal to minus C1. Okay, so any way you do it, you get the answer. So I have C1 root 3 plus or minus, because C2 is minus C1, so minus C1 equals 2. And this simply means that if I factor, let me do it here. If I factor C1 out, I have C1 into root 3 minus 1 equals 2. Okay, and this simply means that C1, okay, this means that C1 will be equal to 2 over root of 3 minus 1. Root of only 3 minus 1. Okay, I hope you get this. And then we say C2 is minus of this. Okay, so this obviously, let me write it here. Okay, let me write it in that. We are saying C1 is equal to 2 over root of 3 minus 1, and C2 is minus of C1, so this will be equal minus 2 over root of 3 minus 1. And then our particular solution will be equal to, we are saying C1 sine of 2x, so C1 is what? 2 over square root of 3 minus 1 sine of 2x. Then C2 is minus 2 over that, so I have minus 2 over square root of 3 minus 1 cos of 2x. Okay, so I can simply factor 2 over square root of 3 minus 1 out, and I have sine of 2x minus cos of 2x. There's supposed to be a 2 here. Okay, so this is your particular solution. I hope this process is very simple. So when you're solving differential equations, your first solution you get is always a general solution, and you always get constants in it. Okay, so in order to get rid of those constants, you need to use some boundary conditions or some initial conditions. Okay, and I said that when you have your conditions evaluated at the same point of s, let's say you can say y of 0 equals something. Okay, y of 0, or let's say y of 2 equals something, let's say t, and if you have y prime of 2 equals, let's say t squared, then this means that this is an initial value problem, because these two are evaluated at the same point. Okay, they are being evaluated at the same point of x. But if, let's say, I have y of 2 equals, let's say, t, and then I have y prime of, let's say, 0 equals t squared, or let's say 2t, then these values, since they are different, you call this set of conditions boundary conditions, and we call this one initial conditions. And then problems that comes with initial conditions are called initial value problem, and then problems that comes with boundary conditions are called boundary value problem. Okay, so this is the lesson I have for you today. Thank you, and Kindly subscribe to my channel if you have not subscribed. See you next time.